Here's a question which explores the idea of average speed, which can be something that students find confusing when they first see it for a reason that I'll discuss shortly. So this is a relatively simple problem that illustrates this idea quite well. And this is the kind of question that you'll probably see as a high school student or maybe in your first year of university if you're doing something like maybe physics or some form of engineering. And if you'd like to see anything similar to this, let me know in the comments. Now, this is the problem. We're dealing with a car which travels four equal distances in succession. Each distance is traveled with speeds v1, v2, v3, and v4, and each of those speeds are 1 meter per second, 2, 3, and then 4. And the question is, what is the average speed of the car over the whole distance? Okay, so what's the first thing that, let's say, an average student would do? Well, because they're asking for the average speed, they would say that the average speed is the sum of all speeds, and then you would divide that by 4, right? Because this is what the mean or the average seems to be from a mathematical point of view, and then you would get 1 plus 2 plus 3 plus 4 over 4, which is something, which is 10 over 4, which is 2.5 meters per second. Now, this is not the correct answer. Why is it not the correct answer? It's because the average speed is not defined in this way. So the average speed has a relatively straightforward definition, but that definition and this definition are completely different. So the average speed in physics, or in general, I should say, if you have a distance, let's say AB, and you have a car traveling this distance from point A to point B, and let's say that the speed of the car changes, like it happens in this problem, right? So maybe the speed is greater at the beginning, and then at some point it slows down, and then it picks up some speed again, and then it increases, and then when it gets to the end, it decelerates. Okay? Which is something that, could happen. For example, if you're driving in a city, if you have traffic lights, you have to stop, then you have to accelerate again, and so on. But the average speed, this v dash or v bar, is simply defined as the total distance divided by the time t. So this is the time it takes this car, this object, to travel the distance from A to B. Okay, so that's it. That's what average speed is the total distance over the total time. So although the speed of the car is changing all the time in real time, okay, this idea of average speed is answering the question, okay, if I start from point A in the same time as this other green car, okay, what speed should I have? What constant speed v dash or v bar should I have to reach point B in the same time as the green car, which, whose speed is always changing from A to B? So what speed do I need to have? What constant speed do I need to have starting from A so that I arrive with the green car at point B exactly in the same time? And that is the idea of average speed. That's one way to interpret average speed. Now, there is another way that we're gonna have a look at shortly. So let's imagine that this is, well, this is clearly a coordinate system. And let's consider velocity against time. Okay, so let's say that our car starts with 0 speed, and then the speed can increase, and then it decreases, and then maybe it increases again, and then it goes down to 0. So you see that in this case, the velocity is changing, so technically finding the total distance that the car travels would have to be done using an integral, right? So this area is the distance traveled by the car. So now the question is, how do we find the average speed from this? Well, if this is the distance, then the real question is, where should my constant speed v be placed on the y-axis? So where should it be a bit higher? Should it be a bit lower? Such that the area of the rectangle which is between this y equals v dash and the time axis between 0 and the time it takes the blue car to come to a stop. The average speed is such, or it is chosen as such, so that the area of the rectangle and the area of the green, the green area, the area under the blue curve, they have to be the same. So when the area of the rectangle, so when area of rectangle equals the green area, then this v dash is the average speed, which from a more intuitive point of view, it's exactly what we discussed earlier. So what should the constant speed be of this red car so that it arrives at point B in the same time with the green car whose speed is always changing? And from a graphical perspective, it's the same as saying where should the coordinate of this rectangle width be on the y-axis, so that the area of the rectangle equals the area under that curve, okay? And that's the average speed. So let's actually use that to solve this question. So a car travels 4 equal distances in succession. So we're dealing with a car that travels a total distance, let's still call it AB, and we're gonna split this distance in 4. So we have, this is the middle, this is the middle of the middle, or the quarter, and like that. So each distance is traveled with a different speed. So this distance from A to, well, let's call this, let's try to give some names here. Let's call this lowercase d. This is also lowercase d, right? So because all the distances are equal to each other. So each distance is traveled with a different speed. So we have the first distance d is traveled with v1, then we have v2, then we have v3, and then we have v4. Okay. So as we said earlier, the average speed is the total distance divided by the total time. So the total distance is 4d, right? That's the total distance traveled by the car. And the total time, well, we're gonna find an expression for that as well. So the total time, if you think about it, is the time it takes the car to travel this first quarter, which is, let's call it T1, plus the time it takes to travel the second quarter, plus the time it takes to travel the third quarter, plus T4. So this is the sum of the 4 times needed to travel each distance, like this. Okay, so the total time, therefore, is T1. And what is T1? Well, T1 is the time it takes the car to travel from A to, let's call this maybe A1, this is A2, and this is A3. So the time taken for the car to travel from A to A1 is simply d over v1, because it travels that first distance d with a constant speed. So the time is just the distance over the speed v1 plus, and then for the time t2 we have d over v2 plus d over v3 plus d over v4, like this. Okay, and that's the total time. So the total time is made up of the sum of all times that the car travels each segment. Okay, so v dash is therefore going to be 4d over, and instead of total time, I'm going to write this expression instead. So this is going to be d over v1 plus d over v2 plus d over v3 plus d over v4. Like that. So let's see what we get. Let's move this to the next page. Now, you should be able to see at this point that the distances cancel out, which is in a way what we expected. So the question tells us some information about the velocities, the speeds, the v1, v2, v3, v4. And the question is about the velocity as well, which means that the final answer, this v dash must only depend on the velocities, which seems to be the case. And that is how you find the average speed. So let's actually put the numbers in here. We have 4 over, and then we have 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 4. And if you do the math, you should get something which is approximately 1.92 meters per second, which, as you can see, is not the same thing that you would have got if you did the problem the wrong way, which is this. Okay, so let me just cross this out. This is not the correct way of getting the average speed. You don't just add the speeds, you divide by however many speeds there are, and you get the answer. So the average speed is given by total distance over total time, okay, which can be interpreted graphically as well. So you want your average speed to be this point here, which gives you a red area of a rectangle, which is equal to the area under the blue curve. And that's the end of the question.